Hello and welcome to the second video of the tutorial series for the COVID-19 simulator developed as part of the EUVABECO project. I will now guide you through the available analysis tools for the simulation results. In the Results section, the Plots subsection shows the trajectories of the epidemiological data and influential variables over time. Observed data is depicted as points, model simulations as lines, and confidence intervals as shaded areas. You can switch between a linear or a logarithmic y-scale by pressing Log. Extend a plot by clicking on the 4-arrow symbol. To zoom into a plot, drag the mouse across the area you want to enlarge. To zoom out, double-click in the plot area. To shift the X and Y axis, drag the mouse along the axis. Hover over the plot to see the numbers for each respective day. In the Metrics subsection, you can find various summary metrics, such as the highest incidence simulated during the simulation period or the total number of new cases. In the Overlay subsection, you can compare two metrics on a single timeline to identify correlations and time lags between epidemiological indicators. For example, when comparing daily deaths to incidents, there are shifts in the relationship between the two. But when comparing deaths to hospitalizations, they follow each other more closely. In the Trends section, you can see the growth rate. This answers the question of how fast cases or deaths are increasing each day. It compares today's total to the total from 7 days ago. Higher values mean faster spread. For cumulative data, growth is always positive. Red sections indicate speeding up, green sections indicate slowing down. In the Lag Analysis subsection, you can analyze the time shift between two metrics. For example, when comparing daily deaths and incidents, we see that the calculated optimal shift is 12 days. Using the slider, you can see that a 12-day shift optimizes the correlation and overlays the peaks of daily deaths and incidents. In the Calendar subsection, each row shows daily values as a heat map, while each column represents 1 week of the year. Here you can compare the overall pandemic trajectories of the different metrics. In the Peak Timing subsection, you see the time delay between peaks of different metrics. These delays reflect the natural progression of disease. Increased transmission leads to more cases, which leads to more hospital admissions, which in turn leads to more severe outcomes. However, different disease severities caused by virus variants also play an important role here. In the Epidemiology section, you first see a wave detector. It uses smoothed incidence data to identify distinct epidemic waves. A wave is defined by a peak that rises above 10% of the maximum value, with at least 21 days between peaks. In the Outcome Flow subsection, you can see a visualization of the flow of patients through the healthcare system, including the number of all patients and the fraction of patients in each state. In the Ratios subsection, you see the cumulative case fatality rate. This is the number of total cases at a given time divided by the number of total fatalities. The ICU to hospital ratio is the number of ICU patients divided by the number of total hospital patients. It differs from the fraction of patients requiring ICU treatment, as patients in the ICU generally have a longer hospital stay than those who only require general ward treatment. Finally, you can compare different scenarios, which we will show in the next tutorials. In the Threshold subsection, you can define different thresholds for each metric and receive an analysis of the number of periods, as well as the total number of days, during which the metric is above the defined threshold.